Hello guys, welcome again. From this video I am starting a new series in Go language for data structure. So far we use only C language or C++ language for data structure, and mostly we use C language. But here Go is a new language that support pointer also. From this video we will learn how we can create linked list, stack queue, circular linked list, W linked list, or other kind of data structure, how we can create in Go language. So in this video we are going to understand what is simple linked list and how we can create this simple linked list in Go language. That we are going to understand from this video. In later video we will discuss about other data structures. So first of all we have to understand the array. You see I have a this diagram in MS Paint. That array having a some value like 49, 40, 23, 67, 87, 24. So array have a continuous memory location. So this is the value 49 and 100 is the location. 23 is the value, 104 is the location. If we see, if we feel that this integer take 4 byte of space, so first is element in array having a 100 address, then second would have 104 and third will have 108, and if we have a 64 bit of space, then we will change in 8 bit. So 100, then 108 and then 116. So that will convert as per the size of the integer or some other value which we want to take. Here we are suppose that we have an integer of 4 byte. That's why we are changing the address in a difference of 4. But if I use same information I store in linked list, then the scenario is different. In linked list, first of all we have to add a one node like this, and this node will have a two part. So first part here will have a value, we say 49 for example, and we feel that this node having a address 100 for example. Now this second will have a nil or null. I am talking about Go language. Go language having a nil, do not have a null. So I am talking in reference of Go language. But if I talk about C language, then I will say null. But in Go language, I talk about nil. So if it is a one single node, and I say this node is A, this is A node. So having 49, so it have a minimum two part. First is information, second is the address of the second node. So because it's a single node, so do not have a second node address, that's why it's a nil. But if I store 23 for example, so it will be somewhere else in a memory like this, and I say we have a two part. So first part we have 23 like we have in array, but the address of this particular would be 200 like this. It doesn't mean that the address would be 104, because this address may be anywhere in the memory. So here we will have a nil because it's a single one null value, and we say it's a B node. But if we will link these two nodes, then if I link this node to this one like this, that means this nil will have the address of B node. So we remove this and we have to pass here the address of node B like this. So from the A I can go to B. If other value I insert, suppose 61, 67, and I say this value is stored here like this, and maybe the address of this node is 112, and the value here we have 67 and we have nil also here. So if we have a simple linked list, that means this node will be linked with this node here. So that means I say this is node C, and C node address is we have here with the B node. So I write here C, like this. So A having an address of B, B having an address of C, C having a nil. But if I say one more node here, we have one node here, and again I just add new node. So this node also having a nil at the end, like this. This is node D, and I say the value is 87, like this, and the address of this is 216, like this. And if we link this with this node, that means the nil will replace with the D. C will have the address of D, like this. So you see, it's just we having the linking between these node, and this kind of data structure is called simple linked list. And remember that every time whenever we add a new node, for example, I add one more node, here I have a node and I want to add this node to the D. So D is not the simple node, so I can directly access, because I don't know the address of this D. Only C know the address of D, and we have to add this. This should be nil and the value should be, I think, 24, for example, and the address of this is 300, for example. So if I link this one to this node, that means I have to start from node A. So I will start from node A. From A I will go to B. From B I will go to C. From C I will go to D, and then I will get the address of D, and D address having a nil at the end. So I will replace this nil with the address of D. So I say here E, address of E. So this last node is E, like this. So that's why it will link. So again, if I want to add node, then I have to reach to E, then I will add the next node F. So that means each and every time we have to start from a node A and we have to reach to the last node, then we insert a new node at that previous or last node. That is called simple linked list. We have other linked list also, but that scenario is different. Here I am talking about simple linked list. That's why we always have a head node, and that head node must have an address of node A. So we always keep this node head safe from losing the information. That means we cannot change the value of head. If we lose the head, that means we will lose the complete linked list. We cannot get back, we can't get back the linked list again if we lose the address of A, because address A node having a address of B, B having a C, then C having a D. So all are linked only with the node A. If by any wrong coding by chance we lose the address of A, then we will lose the complete linked list. That's why we should keep safe this head node, because it's my starting node. So from this node we can travel to other node in a linked list. That is all about the simple linked list, and that we also do in C language. So same concept we are going to implement here in Go language. We will create a head node, and from the head node we will go to the other nodes, and we will learn insertion and reading the node in this video, and the other, like deleting a node from the simple linked list, or we have the deleting from the beginning from the first node, deleting from the specific position, deleting from the last, and inserting at the beginning, inserting at the last, and inserting at a specific position. There are so many operations in linked list that we will discuss one by one in different videos, but here I am talking about simple linked list. Then I will talk about circular linked list, then I will talk about the operation in circular linked list, then doubly linked list. So there are so many linked list operations and types of linked list are available. Then we have a stack and queue also. So all we do, so this is the theory to understand this. Now we are going in here and a practical. So we have to create a package like this, main. Now I have to create a main function for here for starting. Then we have to create a structure also, and I say linked list, I say struct, and here I take number int type for storing information, and I take next node as a address of this. So next node will be stored here, one is a number. Then I create the head node, so I say head and equal to new linked list like this. So we have a head node here, so we declare the head node. Now from this head node we have to create the functions, so for insert function and for display function. So I say func, and I say head node linked list, so this is a method, and I say insert, and here in insert what do I just pass the num int type like this, and I insert a head. So first of all I need to create a temp variable, so I say var temp equal to address of linked list, so I create this one. Like this. Now for temp I need to create pass a value dot number, so I say num like this, and temp dot next should be nil, because I want to insert the new node at the end. As we have seen in the diagram that always I am going to insert the node at the end, so this node always have a nil, so that's why I'm creating here nil. This is a new node, and this node I will link with the previous linked list. So I check first of all if my node is equal to nil, means if there is a nil, it's a first node. If it is a first node, here no information is there, then we pass this to the node like this. Else if it's not a first node, that means we have to start from the first node and we have to reach to the last node for inserting a value. So for that I have to create one more node. I say p equal to address of linked list like this. Then I pass the address of p to node like this. Remember that we don't want to lose the address of first node. This is the address of first node which we will pass. So I don't want to waste this address, that's why I'm passing in p. Then I say for p next not equal to nil, until we do not have a nil, then p equal to p dot next. We are traveling toward the next node, and at the last we say that p dot next equal to temp. At the last we will add this temp at the last. So this is for insert operation. For display operation I say function, we can say method, because we are linking this with the structure, so it is called method. So method, and I'm passing here node again linked list, and I say display like this, and here I say we create a node p and equal to address of linked list like this, and then I pass the address of node here. Then I start for p not equal to nil, then I have to display fmt dot println, or I can say printf, and I say percentage d, and then I display this value to linked list, and I say p dot number. and after display this, and I travel the P to the next node like this, and here I create the information like I just fmt dot println, and I say enter your choice like this. Then I say fmt dot println first choice is insert value in linked list. Okay, like this, fmt dot println, and remember I have to repeat this task, so I put this in for loop, and for I say for always true like this, and I put this one here, and here I say second choice is display display linked list. So I will have two operation only, and next one is the last operation that I say here exit. Okay, so if I take a choice, so choice will go to the variable. I declare one variable, I say choice like this, and that would be of a string type. I say string like this, string type, and here I say fmt scan f, and I say choice like this, and switch choice like this. If we have a case 1, first choice we have, then I say head dot insert, and I will pass the value here, and if there is a case second, then I say head dot display like this, then I have a default, then I say os dot exit like this, I save it. Here for insertion case, I will take value from the, so I say I create a variable, I say where data int like this, and I say fmt dot println enter your value for link, enter your value for linked list node. Okay, and that would be because we have to convert it, so first of all I have to take insert a string, and because it taken in string, so I say fmt scanf fmt dot scan fl, and I say data, then I have to convert it to num error, and I have to convert this to str conversion dot a to I, and here I pass data like this, and here I pass num. Save it. So I try to create the simple linked list for insert and display. So for display we have printf like this. So I try to execute it, cd data structure, then YouTube, then I say go run, and I say link.go and try to compile this. So it asking for choice, I say first choice, so I say 23 value. Again it asking for choice, I say first choice, I say 56, and I click on choice 2 for display. You see linked list is displaying 23 and 56 same, but starting from a 0. So I have to remove the 0. So I say node dot next. So we have to pass from this second node here. Then I close it. Once again I started. I say first, I want to insert a first node. First node inserted. Display. So first node is coming. So I have to once again display enter your choice should be a /n in the beginning. Okay, I save it. Once again I start to run and I say enter your choice. Choice is 1. So first choice is 23 value I insert. So I say display my value. So first linked list is display 23. I insert one more value 56 and I say display. So 56 is also coming. Once again I say 67 and I display it. So next value is also coming 67. Once again I say insert, I say display. So one by one you see my linked list is growing. Okay, so this value 23 was the first head node, then 56, then 67, then 89. So two operations we have performed here in this video, and we have learned how we can create a linked list in Go language, how we can insert a linked list node in a linked list, and how we can display the same linked list. And we have the same operation. I can grow this to any number of length. You see again and again I am just inserting a value, and at cycle by mistake I close. So once again if I insert, I say this one more insert value, one more insert value, one more insert value, and display. You see I can grow this linked list to any number of length as per the memory available here. So you see simple linked list, insertion and display operation. So if you really like this video, kindly do subscribe my channel, and thank you for watching this video, and see you in next video for the same series.